Video number 3 for section 8.2.1, Introduction to Imaginary Numbers. We've already talked about the definition of I and where it comes from. I squared is equal to -1. That can help us simplify some things. So let's take a look at example number 6. Okay, and remember we said before doing operations on imaginary numbers, let's get them into their pure imaginary form first. All that means is let's get rid of the square root. And we have done that. That's already done for us here. Okay, remember, although I means something different than another variable, they act the same way as a variable when you're adding, subtracting, multiplying, and dividing, at least at first. There are some special rules for simplifying when you're multiplying or dividing that we'll talk about in a little bit. Okay, so here, 2i plus 5i minus 9i would be exactly the same as if this said 2x plus 5x minus 9x. You guys knew how to do this before you knew anything about imaginary numbers. Okay, 2 plus 5 is 7. 7 minus 9 is -2. So -2i is what that is simplified. Same as it would be if that was any other variable. Okay, here we're showing multiplication. So if we multiply together, -5 times 5, we get -25. And we multiply together I times I, we get I squared. Now remember, we talked in the last video that I squared is always equal to -1. So this really says -25 times -1. So our final answer here is positive 25. Okay, it's a little weird, something we're not used to, a positive times a negative becoming a positive. But again, we're talking about imaginary numbers, so they're going to do a little bit different things than what we're used to. Okay. This last one, same concept. We know we have to do the exponent before we multiply. So the 3i stays where it is for now. When I square, I have to square both parts, so it's 25i squared. And before I even combine the I with the I squared, again, let's remember, I squared just means -1. Okay, so this second parenthesis just means -25. I squared equals -1. 25 times -1 is -25. So 3i times -25, again, treat it like any other variable. Negative times a positive is negative. Okay, there aren't two i's anymore, there's just one. 25 times 3 is 75 times I. Okay. There we go. Here we started off with all positives and somehow we got a negative. It's okay. It came from the fact that there was an I squared that turned us negative. Okay. Now, real numbers are what you've known your whole entire life. Imaginary numbers are what we just started talking about today. When we put real and imaginary together, we get what's called complex numbers. Okay. This is the real part, just the a value, and this is the imaginary part. And when we put them together, we call it a complex number. Okay, this is really just vocabulary, and it's reminding us that if we have a real and an imaginary part together in an expression, we do always put the real first and the imaginary second. As we know, a could be a positive or negative number, so could b. This could be positive or negative. Okay. Speaking of vocabulary, let's talk about the vocabulary of complex conjugate. Okay, again, this is just a definition. These are just words. You have to know that the complex conjugate of the complex number a plus bi is a minus bi. Okay? If you notice, the only difference between the complex number and its conjugate is this middle sign. It's not both signs, okay? The a value or the real portion remains the same sign, and the imaginary portion is the only part that switches signs, okay? So let's take a little bit of a look as to what this is going to look like. So everything on my board right now is considered a complex number, okay? The real parts of the complex number, -6, 0, 10, and 3. The imaginary parts of these complex numbers are 2i negative 4i, 0i, and negative 7i. So remember, a complex number is just a real and an imaginary put together in one expression. Even something like this can be considered complex. You could also just call that a pure imaginary. This, a counting number that we've seen for so long in our lives, this is also considered a complex number, even though we know it's just a real number as well. Okay? If I wanted to write the conjugates, remember, all I'm doing is switching the sign in the middle. The negative 6 stays. It's still 2i, but we're just switching it over to negative. Okay? You'll see tomorrow why this is important. You're probably like, why? Who cares? Why are we switching? Tomorrow you'll see why that's important. Here, there is no real part, so we're still only switching the imaginary part. 4i is the conjugate to negative 4i. Here, there's no imaginary, so switching the signs of the imaginary doesn't do us any good. The conjugate of 10 is 10. This is actually very uninteresting, even with what we're doing tomorrow. Okay? And the conjugate here, again, leave the 3, whatever sign it is, change this sign, okay, and then we have our complex conjugates. Okay? One more video and you guys are done for today.